Just like infrastructure, the planning of the infrastructure is a long and complex process, and it typically involves multiple steps. So let's go over a few of those important steps. One of the first steps in the infrastructure planning process is the establishment of goals and objectives. There are entire classes that focus on goal setting and developing objectives. It's important enough that just about every plan you'll see, short-term or long-term, will start with a goals and objectives section. This is where planners and policymakers, working with stakeholders and members of the community, work to develop the purpose of the project or plan. Putting these goals and objectives down on paper will help keep the project focused throughout its various development phases. It also serves as a useful tool to evaluate the successes and failures of the project later on. Lessons learned from this process can feed into the enhancement of future infrastructure planning processes and can help make those processes much better. Step number 2 typically involves problem identification and analysis. So this is pretty straightforward. Planners go out and decide what the issue is and figure out what the process behind alleviating that problem will be. If you have congestion on a road, how do we address that problem? Then you can go into solution finding, searching for the right set of solutions or single solution that might address your problem, and then conducting impact analysis. That impact assessment is typically done across all the different dimensions of social, environmental, political, and economic sustainability planning. So for example, the New Zealand Transport Agency has a very detailed and thorough approach to this assessment, where they will consider the different impacts to those dimensions. Road and rail projects can have significant impacts on all of these dimensions, and the analysis can be quite extensive.
Before we start looking at what option might work for the project, we look at what the environmental constraints of the project area are. So those constraints could be things like the significant ecological areas or watercourses, and heritage sites and areas, and also through the identification of the growth areas of Warkworth and Wellsford and community resources such as the wastewater treatment plant and the stockyards. We also identify significant utilities and services such as the gas lines and the high voltage transmission lines and the railway. We also talk to people like Doc, who are a major landowner in the area and know quite a lot about the ecology. The root protection process is identified in the Resource Management Act, which sets out the whole process, including developing an assessment of environmental effects. That assessment includes a preliminary design of the project and the broader boundary, and technical assessments which are used to inform the assessment of the project. All of that assessment supports a notice of requirement which is submitted to the Environmental Protection Agency, which shows the project on a drawing set, has the assessment of effects, and identifies the land that is required for the works, or the designated land. The Transport Agency will need a range of approvals under different acts. There's the notice of requirement as described previously to get the land designated, and at the same time the Transport Agency will seek resource consents for the earthworks and for the structures such as bridges which are required to build and operate the project, and also for permanent stormwater discharge from the road once it's built. Other resource consents might be around management of contaminated land, diverting streams and groundwater diversions and discharges. And all the information described in the AEE will be used to get these approvals. The Transport Agency will endeavour to engage widely throughout the project area with interest groups and affected landowners and the neighbours of the project. In addition, there are key stakeholder groups such as Auckland Council, Auckland Transport, the Department of Conservation and Heritage New Zealand. The Transport Agency will work closely with its iwi partners through the whole project. That feedback would be taken on board as part of the process to refine the design and the location of the proposed alignment. And where the feedback cannot be directly adopted or addressed, this is acknowledged through the consultation summary and the documentation for the consents and notice of requirement. Consultation will carry on once the applications are publicly notified to try and resolve stakeholder and submitter concerns. Some of these concerns can be addressed through resource consent conditions and designation conditions where possible. The Transport Agency will achieve the environmental outcomes through the conditions of the designation and the resource consents. These will outline the environmental outcomes required for the project. The consents are implemented through the construction and maintenance of the project, and the Council also undertakes independent compliance monitoring. Many of the conditions require ongoing obligations, such as replanting landscaping where it hasn't established and maintaining the stormwater ponds to ensure they operate to achieve the right water quality.
Next, we go to the formulation of alternatives and analysis. So in addition to examining the costs and impacts of a proposed project, agencies typically also need to examine the potential for alternative projects. This isn't just an alternative way to design or construct a project, but alternatives to that investment altogether. So again, for example, NZTA may look at expanding a road, but as an alternative, they may also examine potential to reduce future demand for that road by providing more bus service, more bike lanes, or some other competing project. The objective here is to determine the best use for a limited set of investment opportunities. This assessment is typically carried out with multiple detailed cost-benefit analyses, and the project or projects that show the best financial and social returns are the ones that go forward. Recommendations are given to a governing body, whether to a local government council or the central government committee or some department. This is the most obvious political dimension and where careful consideration of the political feasibility of the project or set of projects is required. There's no point in putting forward a recommendation if it is simply not politically palatable, no matter how great we as planners might think the project is. And close to the last step is the decision process. The government agency will then make a decision based hopefully on the careful analysis put before them, but realistically, on a number of factors that are out of the planner's control. And getting close to the end of this pretty long process is implementation. Once a decision is made and the necessary political and physical hurdles are cleared and the RMA process is completed, then the project can be implemented, which is the construction and delivery of the project. Once the project is built, it's up and running, comes the management and operation of that project. Despite our best planning efforts, there are bound to be any given number of unforeseen events that could have an impact on the infrastructure planning process. As I mentioned in this course introduction, the world, even now, feels like a completely different place than it was at the beginning of the year. This pandemic will undoubtedly have a significant disrupting impact on many of our infrastructure plans. While we can't predict what we can't foresee, we can better plan for unexpected events to provide a range of options if something does happen. A good example of this is the Shell Oil Company's work in the 1970s on scenario planning, credited with saving the company during a series of unforeseen events.
We have our 40th anniversary of Scenarios in Shell, and it was a man, Pierre Vac, who put this on the map. And that was at a time when a lot of the Western oil companies were just planning on the basis of sort of more production from the Middle East and business as usual carrying on. However, Pierre Vac was a very bright man, and what he pointed to was about how what he called the rapids, the volatility in the world would rise as the Middle Eastern countries decided to nationalise those assets.
We were beginning to sketch out possibilities of the kind of development that led to OPEC, which completely changed the energy industry at the time in the 70s. In the 80s, we were looking forward and beginning to see the kinds of political developments that culminated in the fall of the Soviet Union and the Eastern Bloc.
A lot of people had discounted that Russia might emerge and move into the world stage. There was the oil price collapses of the 1980s. A lot of the conditions there with the softening of demand but the rising supply were in place for an oil price collapse that a lot of people weren't ready for and didn't see, but the Scenarios team had.
In the 90s, there were the forces of globalization, market liberalization, and information technology that were transforming the whole of society. And also, we could see environmental pressures building up.
One of the scenarios was about the real breakthrough and the real acceleration of China and the way that its development could be transformational. And I think we were ahead of the curve there in charting the way that that might have a really significant impact on the energy system.
We had a number of other milestones, like bringing sustainable development on the map, bringing the importance of gas as part of that on the map. We have explored many other things like disruptive technologies. What if electric mobility would really take off, and in what form?
When you look from the 2000s, you begin to see also the impact of the demand surge in resources as prosperity and population boom, and also the constraints on supply that lead to a new tightness, and are one of the features in what we now refer to as the era of volatile transitions over the next decades.
In the sort of short and medium term, one of the critical questions in the West is how we're going to emerge from the financial crisis. I think over the very long term, there's the question as to how we transition to what we hope would be a more sustainable world. But one of the big challenges, I think, for humanity for the century as a question is whether the people of Africa, people of developing countries all around the world are going to be able to enjoy the quality of lifestyles that many of us in the West have become used to.
We can build the same type of robust planning into our processes by following a few important steps. First, we must identify the nature of the threats that might face our infrastructure, whether it's an earthquake, whether it's a tornado, or whether it's a cyclone or some other unforeseen event like an economic downturn that's really just not that predictable. Once we identify the nature of the threats, we have to assess the risks that might be associated with those threats. An earthquake is pretty significant and short-lived. An economic downturn can be a long-term issue that requires new infrastructure to support the existing. So we have to really chart out all the different ways in which that infrastructure might be impacted by all the different events. Next, we really have to identify and compare the alternative protective measures that must be taken. So how do we fortify our infrastructure? It's pretty straightforward with an earthquake. We have different types of construction, different ways that infrastructure can withstand an impact from an earthquake. But again, something like an economic downturn is much more difficult to predict the ways in which it might influence our infrastructure and finding measures that could protect it. Next, we need to identify and compare all the different responses that we might be able to take after that event. We then develop appropriate recovery actions to return damaged or degraded facilities into productive use. So this is really what's important about resiliency in infrastructure, which goes hand in hand in sustainable infrastructure in a way. It's the bounce back effect. How quickly can our infrastructure return to some level of normal use? And this has a lot to do with the planning process beforehand, building in robust ways in which our infrastructure can withstand an impact of some type, and then also ways in which that infrastructure can be recovered very quickly. Last is estimating the extra costs associated with a program and defining the ways in which we can finance them. Building infrastructure itself is not cheap. Building robust infrastructure that can withstand a variety of different potential impacts is very expensive. So figuring out a financing mechanism for that is critical to building sustainable and strong infrastructure into the future.